Okay, my last video showed how to calculate the volume of this object using the interpolation function within Mathematica to give us an estimate of f of x's from one point to the next. Now there's another way to do this without without using that interpolation function or even integrating, because if you do not have an f of x, there's no way to integrate an f of x along the way. So the next best way to do that would be by using Simpson's rule. Now Simpson's rule allows us to take points along any shape of any object, and by using those points we can estimate the area under the curve. And all we're going to do is exactly what we did if we had a function. In this situation we took our function, we squared it, and we integrated from a to b. Well, we're going to do the same exact thing, except we're going to use Simpson's rule to determine an approximation of this area under this curve, and we're going to square it and rotate it about the x-axis to determine the volume. Now here's Simpson's rule. It states that b minus a over 3n multiplied by an f of x, your initial point, times your second point, or plus your second point, times 4, plus your third point times 2, fourth point times 4, and so on until you get to your final point. My n represents the number of intervals that you're going to be using. In my case, there was 37. So all I'm going to do is modify this a bit to calculate the area under the curve and rotate it about that same x-axis. All I've done here, as you notice, I added pi, just like I had here, pi. Now we can't integrate, so what we're going to do is use Simpson's to estimate the area under the curve and square each one of these. So the only real difference here is that I've added pi and I'm squaring each f of x along the way. Now I use Mathematica again to calculate this. A equals 0, b equals 11.475, n is number of intervals. Again, I have 37. This is my first interval squared. My second, or I'm sorry, interval, I should say, my first point squared. My second point squared times 4. Third point squared times 2, and so on. All 37 of them. And if this is my end result. It gave me an approximate 45.58 cubic inches, which is really close to what Mathematica gave us when it calculated the f of x of 46.6. So again, here's the Simpson's rule, basically